Okay, I'm going to do B and C together here because they're about the same problem here. In the previous video in 3A, we came to the conclusion that this block would be sliding down the plane, right? And the masses canceled, and we got that it would accelerate, that the acceleration of this thing relentlessly is down the plane is 5.6268 meters per second squared. Now, since there's no force of friction acting along the plane, as it slides up the plane, it will be accelerating down the plane that way, and as it slides down the plane, it will have the same acceleration. That's only true if there's no friction. Now, if there is friction, it will accelerate up the plane. It will decelerate more quickly up the plane. Anyway, you'll see that. That'll be in I think problem 5. Okay, but anyway, let's just go with this. All we have to do is SUVAT this, right? It's given a velocity of 5 meters per second up the plane, and we want to know how far up the plane it goes, and the time it takes for it to come back to where it was released. So let's go here this thing is, right? Let's figure out how high it goes up the plane, and then we can figure out the rest of it. It's pretty simple. This is very similar to the rocket launched up in the air with some velocity. How high does it go? What time does it take to get back to the ground? Only the acceleration here will be negative 5.6268 meters per second squared and not 9.81. Okay, so at the top, it's 0, right? Our velocity is 0 because it's not 0. It's not at the top. Our initial velocity is positive 5.0 meters per second, right? Because that's up the plane, and up the plane is positive, right? This acceleration is negative because it's going to accelerate down the plane. And it will do that while moving up the plane, right? Let's see. So we want to find, what do we want to find? We want to find S. I think our friend is just V squared is U squared plus 2AS. So S is V squared minus U squared over 2A. So that's 0 squared minus 5 squared over 2 times negative 5.6268. Okay, so the numerator is negative, denominator is negative. It's going to be a positive number. It's going to go up the plane and not down. Okay, so 5 squared divided by 2 divided by the thing that I stored in A. And I get 2.22 meters. Right, so there's that answer, right? Okay, and then it says how much time does it take to come back down to where it was released? To find the time, what I'm going to do is I'm going to find this time. That'll be half the time, right? Because it's going to spend half the time up and half the time down because it's symmetrical. It'll accelerate down the plane just as rapidly as it decelerated up the plane, right? So to find the time, I'm going to use A is change in velocity. Oops. I'm going to use V equals U plus AT. Let's just use that. That's the simplest thing, right? So 0 equals 5 plus V equals U plus AT. So let's do this. We could do it. We could do it. V equals U plus AT. Right? So 0 equals 5 plus negative 5.68268 times t, right? So it's negative 5 divided by negative 5.62, whatever, right? So negative 5 divided by... And I'm getting that the time to go up is 0.8886 seconds, right? That's the time up. It's going to take a 0.8886 seconds down, right? That's going to be up. It'll be down. Right, so I'm just going to multiply this by 2, and I get 1.77777. That's kind of cool. Seconds to go up and down, right? So I use this guy, believe it or not. Sorry about the mess, right? I use this guy to find t, right? And then multiply the t by 2 or add them together, right? That time up, that time down. Now, just be careful. If there's friction, it'll take a lot less time to slow down going up than it does to go down, okay?